In this video, I'm going to be explaining how to find derivatives of natural exponential functions, or e raised to some power. The rule in most textbooks will be explained like this. The derivative of e raised to some power is that same function times the derivative of that exponent. So if you just remember that rule, that the derivative of e raised to some power is just itself times the derivative of the exponent, it's a pretty easy rule to remember. In its most basic form, the derivative of e to the x is e to the x, because the derivative is going to be the same function or original function multiplied by the derivative of the exponent. The derivative of x is just 1, so e to the x times 1 is just e to the x. And that'll be true even if you have a coefficient or any constant out in front, because we're just going to take the derivative of e to the x, which is e to the x, and multiply it back to that constant, so we get 2 times e to the x. It doesn't matter what that coefficient is. The derivative is going to be itself every time. It gets a little bit trickier when that exponent has more going on. So combinations of other derivative rules. Let's find the derivative of e raised to the 2x minus 1. The derivative is going to be itself times the derivative of the exponent. So the derivative of 2x minus 1 is 2. Multiply everything back together. The derivative of this function is 2 times e raised to the 2x minus 1 power. So again, it just gets a little bit trickier when you're finding the derivative of an exponent that's a little bit more complicated. We could do these all day long. I'm just going to do one more example. Rewriting things tends to be a good first step. So even if you have an exponent that has a quotient in it, I would rewrite it using a negative exponent. It'll make it a little bit easier. So to find the derivative of e raised to the negative 3 divided by x power, I would rewrite as e raised to the negative 3 times x to the negative 1 power. Then when I find my derivative, I'm multiplying by the original and the derivative of the exponent. So the derivative of negative 3 x to the negative 1 power is 3x to the negative 2 power, and we can just put everything back together. I can rewrite it all on one level using negative exponents. So 3 times x to the negative 2 times e to the negative 3x to the negative 1 power. Or we could take our negative exponents and rewrite them using a fraction form. So x to the negative 2 drops that down. So now I have x squared in the denominator. And e to the negative 3 drops that also down. And x to the negative 1 would make that quotient in the exponent or power position there. So in general, derivatives of natural exponential functions should be pretty easy, just remembering that we're just multiplying itself times the derivative of the exponent.